Hi guys, this video forms part of the Electrotechniques 143 course, and this example is on superposition that you guys should know, which we've handled in class. And this is the example of figure 4.66 that starts on page 146 of the textbook. Okay, so firstly, I'm going to draw the circuit for you guys and then show you what it looks like. Okay, so over here we have an independent voltage source, a couple of resistors, and then we've got some dependent sources. Over here we have a dependent current source with the value of V delta. We have a resistor over here, and then at the bottom we have a dependent voltage source. Take a look at the polarities, be careful of that, with a current controlling this one, and this current is flowing over here, I delta. This one is controlled by a voltage, V delta, and this voltage is sitting right over here. Okay, so V delta over there. Let's just complete my circuit. So over here I have a current source. Okay, so this is what my circuit looks like. I hope you can see it. I hope it's okay. My apologies, guys. I had a bit of a technical issue there with my hardware. We should be fine now. All right, so this is the example that we're going to do some superposition on. Right, and it's on page 146 of my textbook, and this is figure 4.66. Okay, so what we have is we have a circuit that looks like this, containing both dependent sources, right, and independent sources. So superposition allows me to consider one of the effects of one of the independent sources at a time by deactivating the others. But what are we going to do with the dependent sources? So the key is to just leave them as is. And then you need to consider them. That is, you need to also consider their controlling currents and voltages at each step of the superposition process. So that's when you treat each of the individual independent sources. Okay, so the question that we're tasked to do is to find this voltage V0 over here. I'm going to highlight it so we are clear on what we need to do. So that voltage V0, we've got to find that. Okay. So the first thing in superposition, obviously, we are going to, let's consider this 10 volt voltage source over here. And we're going to do, now in superposition, what we're going to do is we're going to deactivate the other independent sources. So we're going to deactivate this current source. And how do we do that? Well, a current source is deactivated by replacing it with an open circuit. So what we're going to do is let's draw out that, but we say step 1, and let's say consider 10 volt source, and we do that by deactivating 5 ampere source. Okay, so that's our first step, what we're going to do. And remember my hint for the tests and the exams, it's always good to show each step explicitly, because that's where we're going to find marks for you. Okay, so if I'm going to deactivate that source, I'm left with something that looks like this. Now remember that when you do each of the sources, you use these little prime coordinates. Okay, these prime indicates that we are analyzing this first source, and when you analyze the second source, this gets a double prime, and so on. Okay, and we're going to summate the effects of those in the end. So what we've got here is V0 prime. V delta prime to I delta prime, and this becomes an open source. Okay, so first things, let's okay, sorry, this is V delta prime. So what is V delta prime? Well, if we look in this part of the circuit, V delta prime, we can say that V delta prime is equal to this current that flows through here. Okay, so if this current, this 0.4 V delta prime, is flowing through this resistor over here, as I show here with this little arrow, then it's going to introduce a voltage source like this. Let's call this V10 ohm. Okay, and I know my polarity has to be plus and a minus, because remember the passive sign convention, as my current flows through my resistor, this is the type of voltage drop that it will induce. Okay, so what is V delta prime? We would like to get an expression for V delta prime. Well, V delta prime is equal to minus V10 ohm. And what is V10 ohm? Well, V10 ohm is merely this 0.4 V delta prime times by the 10 ohm resistor, Ohm's law. Okay, so what we have here is we have V delta prime minus 4 V delta prime is equal to 0. So we have V delta prime has to be 0. Okay, so if V delta prime is 0, well, then essentially we've got a 0.4 times 0 is a 0 ampere dependent current source. What is a current source when it is when it has a value of 0? Well, then in effect it can be replaced by an open circuit. Okay, so if we replace this part with an open circuit over here, if I take that away, cool, so no current can flow through here, so that essentially that branch has no effect. So what I can do is I can remove that completely. So what I'm left over then is I have something that looks like this. Remember, this part of the circuit now has no effect because that current source is 0. That current source is 0 because it's 0.4 times V delta prime, and V delta prime is 0. Okay, so that's why this part of the circuit falls away for this particular example. So I'm left over with analyzing only this component. So I have I delta prime, and I have plus minus V0 prime over here. And I want to get my expression for V0 prime. Now, when we've got two resistors like this and one voltage source driving it on, what's the simplest way for me to calculate the voltage division over this resistor? Well, that's a voltage divider, exactly as I stated over here. So V0 prime is equal to the control voltage, or the source voltage, 10, times the resistor over which I want its value, divided by the sum of the resistors. Okay, so I urge you to review that part of the lectures on voltage division because it comes in very, very handy as we see over here. Okay, so this is, and if you calculate that, this is equal to 8 volt. So V0 prime, as we've seen over here, is equal to 8 volt. All right, so what we've done now in the first part is we've calculated the effect of this first source, this 10 volt source, and we deactivated then our 5 ampere current source with an open circuit. So now we need to take into account the effect of the 5 ampere source, and we need to deactivate the 10 volt voltage source. So how do we deactivate a voltage source? Well, we've got to make its value 0, and we know that 0 volts is measured over a short circuit. So we're going to replace it with a short circuit. This is now the second part of this example. So this circuit, in effect, can be replaced with something that looks like this. Okay, so a short circuit over there. I have my 5 ohm. I have my 20 ohm over here. I have I delta double prime. Remember, we are now working on the second source, so it's double prime. That's plus minus V0 double prime 0.4 V delta double prime 10 ohm plus minus V delta double prime minus plus 2I delta double prime. Okay, and I have my 5 ampere source. Okay, now you guys can analyze. What we want to determine is we want to determine this V0 double prime. Let me highlight it there. As you can see, it's exactly the same spot as my original one. It's just denoted with a prime. So what we're going to do now is we need to solve this voltage, or alternatively solve the currents here and here so that we can calculate it. What technique are we going to use to do that? Well, you've got a variety of techniques at your disposal that we've learned throughout the course, but what I'm going to select is I'm going to do node voltage analysis at these two nodes. So this node there, I'm going to denote it as node A and node B over here, so A and B, and I'm going to select my reference node as this node over here. Okay, so what's the next step that you should do? Well, you should now replace your, make sure that your node voltages are referenced properly with respect to your reference node, which is this node over here. So I already have this node voltage is V0 double prime, and this node voltage I've got to define here plus minus, look at this, it's defined over here, VB. Okay, so let's start off with that now. Now what we're going to do, we're going to look at, so we're going to say, use node voltage equations at A. Okay, so here's my A and here's my B. Alright, so if we use node voltage equations at node A, what are we doing? We're going to define all the currents, the temporary currents flowing out, and then we're going to write those currents as a function of the node voltage, V0 prime, and the other node voltages, VB. Okay, so for this node A, let's say that the first current is going to flow through this 20 ohm resistor. Well, that becomes V0 prime divided by 20, plus the second current is going to flow out through this resistor 5 ohm here to ground, and this is also V0 prime divided by 5. And what about this current here, this current flowing out? Well, we already have a current flowing in of 0.4 V double prime, so I'm going to denote that with a minus sign, 0.4 V delta double prime is equal to 0. And if I simplify this, I can, so this is my equation, I just want to write it a little bit more simply. I can write it like this, is equal to 0. Okay, now, node voltage at node B. This is now, I'm going to write my node voltage equations at this node B. Take all my currents going out, and let's start doing that. So my first current going out is this one over here. Oh, cool. It's already got a value of 0.4 V delta double prime. All right. Now, what about the current flowing through here, denoted as a function of the node voltage, VB? Well, I can say that if I want to, well, I know Ohm's law will come into play because I need Ohm's law to say that what is the voltage drop over this resistor divided by the value of the resistor. So, but now my voltage drop that I'm going to define over it is going to be expressed in terms of the node voltage VB. Well, let's zoom. I'm going to zoom into that part of this part. I want to zoom into this part of the circuit. What I've got here is I've got my little reference node minus plus VB. Okay. Then I've got a voltage source over here minus plus 2I delta double prime, and then I've got a resistor, a 10 ohm resistor. Okay. And I want to calculate what is this plus minus V10 ohm, because I know I can use V10 ohm divided by the 10 ohm resistor to calculate the current flowing there. So if we take Kirchhoff's voltage law in this little loop over here, I get minus VB plus V10 ohm plus 2I delta double prime is equal to 0. So this tells me that V10 ohm is equal to VB minus 2I delta double prime. So this is in effect what I'm looking for. So Kirchhoff's voltage law can be used over here to just make sure that I write my voltage over my 10 ohm resistor as a function of my node voltage VB correctly. Okay, so I've got that, but before I substitute this into there, let's just look at the last current flowing out, and that again is pretty simple. That's just a 5 ampere current source flowing up like this. It's coming in, so remember for node voltage, when you calculate the node voltage equation at a node, you got to say that all the currents are flowing out. So if I say this is flowing out, but the actual current source is flowing in, I use a negative sign. So minus 5 is equal to 0. Okay, so let's substitute this value for V10 ohm that we've calculated over here in. So this becomes V double prime plus VB minus 2I delta prime divided by the 10 minus 5 is equal to 0. Okay, now what we've got is we've got an equation over here that contains this value for VB. This equation over here only has V0 double prime, V delta double prime. This one is V delta double prime, but I'm still sitting with this VB. So I need an additional, what we call a constraint equation, to write VB in terms of V delta and I delta. Because if I have that, then I can solve my equation. Okay, now let's do that. So what I've got over here is I'm going to look in this little loop, but now I know that V delta double prime is defined over this 10 ohm resistor. So if I say plus minus V delta double prime over here and I do KVL in this loop, then I can say that, as I've seen over here, that let's just make some space over here, minus VB going around the same loop plus V delta double prime plus 2I delta double prime is equal to 0. So VB is equal to V delta double prime plus 2I delta double prime. Okay, now I've got that. I can substitute that in here, and then I get something that looks like this. Plus V delta double prime plus 2I delta double prime minus 2I delta double prime divided by 10 minus 5 is equal to 0. These cancel out, and I am left with an equation that looks like this. I've got 4 V delta double prime. Let's just move to make some space. Well, okay, I'm going to substitute this over that one. I've got 4, 10 times 0.4 is 4, plus I've got my V delta double prime minus 50 is equal to 0. So what I then have is 5 V double prime is equal to 50. So this indicates that V delta double prime is equal to 10. Okay. now from that, I've got V delta is equal to 10. From that, I can also now calculate the value of I delta. Okay, so as I was saying, I've got my value for V delta double prime is equal to 10 volt. Let's make some space over here. Okay, so what we've got now is we have got this equation. Remember, for the voltage, the node voltage equation that we calculated at node A. Node A is here. We have 5 V0 double prime minus 8 V delta double prime is equal to 0. I have my value for V delta, so we say from A, 5 V delta double prime minus 8 V delta double prime is equal to 0, and this I can now substitute into that. So I can say that V delta double prime is equal to 8 times 10 divided by 5. So we have V delta double prime is equal to 16 volt. Okay, now final result. What is that? Well, the final result that we have here is just, remember, superposition says that we can now summate the values of V0 prime. We just open the original one. Remember, what I want to get to is I want to get to let me just move my papers correctly. I want to get to V0 prime using my value of V0 using V0 prime and V0 double prime. Well, I've now calculated the value for both of these. My first one, I calculated V0 prime by considering the 10 volt source and deactivating the 5 ampere source. And in the second example, I calculated V0 double prime by looking at the 5 ampere source and deactivating the 10 volt voltage source. So my final result, I'm just going to scroll up over here. Final result, V0 is equal to V0 prime plus V0 double prime, and this is equal to 8 plus 16 is 24 volts. Okay, I hope that makes sense. Please remember to post some comments or ask questions if something's unclear. All right, see you guys in class. Thanks.